So first of all, where does the uranium come from? This is just a picture of a uranium mine. It's a uranium is an element found in minerals in rocks pretty much all over the world, but there's only a few places where it's mined. In 2005, the last year that I have data for, 41,000 tons of uranium was mined worldwide. Um, the biggest mines are in Canada and Australia, and that's where most of the uranium is dug out of the ground from. In the 1970s, the U.S. actually was the biggest mining producer of uranium, but not so much anymore. And when the uranium comes mostly in the form of this rock called pitchblende, and pitchblende is a brownish black mineral. Um, that is found in the ground. It consists mostly of uranium oxide, but it also contains lead and radium, actinium, polonium, various other radioisotopes. And the reason why is because it's mostly uranium oxide. The uranium itself is in the form of uranium-238, but it's always undergoing a very slow radioactive decay to give us all these other problems. And the last stable isotope in the decay series, remember, is lead. That's why lead is found when you find uranium, you're going to find a little bit of lead as well, no matter what. Another mineral in which uranium is often found is tobernite, and that looks different. It's green because it also contains copper. It's just a different mineral. So first of all, the uranium is located, it's dug out of the ground, it's mixed in with other minerals, and so the uranium oxide needs to be separated, or it needs to be separated from the other minerals in which it's mixed in the rocks. So out of the ground, it's mostly in the form of uranium oxide, either uranium dioxide or trioxide, and but it needs to be separated, and that takes energy and money and effort to do. And as it is, that uranium is only about 0.7% uranium-235 when it comes out of the ground, and so it has to be enriched to get it up to fuel grade. Uranium would be about 3% uranium-235, the rest would be uranium-238, and weapons grade uranium has to be about 90% uranium. And so the enriching of uranium to get up to these higher concentrations of uranium-235 is an expensive process. What has to happen is the uranium oxide is chemically changed to uranium fluoride up to uranium hexafluoride. This volatile form of uranium then is either put into a centrifuge or forced through semi-permeable membranes. Because it's volatile, if you warm it up a little bit, it becomes a gas, and then it's forced through these different semi-permeable membranes, or it's spun in a big centrifuge. And what happens is the uranium that's in the form of uranium-235 hexafluoride versus the uranium-238 hexafluoride, this one is going to be lighter. So it's going to, if you're spinning it in some kind of a centrifuge tube, the uranium 235 is going to move to the top, and the uranium 238 hexafluoride is going to move towards the bottom, and so you can then separate and get the uranium-235 separated out. It's expensive, it's tricky, it's a very technological process, and so it's one good thing to control the spread of nuclear weapons is it's just difficult to get the fuel into the fuel grade. Okay, so I have it written down here. So this is how we modify it to the fluoride. It's volatile in the fusion process. And then the depleted uranium, that's the uranium that has less percentage of U-235, is used for casings and armor-piercing munitions. So it used to just be stacked up and thrown away, and they realized that you could make better bullets out of it. So it's also used in a defense purposes.